BGP states are where a lot of people hit the wall. You read a list, you try to memorize it, and it doesn't stick. All you know is that this one does that, and that one does this. Your brain turns to static. What does it all mean? In this video, I answer that question. Although both routers will be transitioning through the states, this video will focus on the view from router 1's perspective. You configure the routers for BGP, which initializes the BGP process. The process is doing nothing to interact with the configured neighbor. It's idle. The process gets bored of this and decides to reach out to router 2. Router 1 sends a TCP SYN to router 2 in an attempt to establish a TCP connection. BGP uses TCP via port 179 to establish a connection. This connection is required before BGP communication for bringing up a session can even be sent or received. The TCP connection is established. Router 1 sends an open message to router 2. The state transitions to open sent because, well, an open was sent. Router 1 waits for an open from router 2. Think of it like this. Two people connect through a mutual party, you, the matchmaker. After connecting, they open up to get to know about each other. In the context of BGP, opening up means sharing information about its configurations and capabilities. Router 1 receives router 2's open message. It doesn't see any red flags and thinks of router 2 as a suitable peer. Router 1 has a special way of telling router 2, and it's called a keep alive message. Each router must receive a keep alive from the prospective neighbor. Keep alives will be sent, by default, the remainder of the BGP session relationship. The BGP session is up. Router 1 is ready and tells router 2 its secrets. The secrets, of course, being prefixes. The prefixes, called network layer reachability information, are shared via a message called an update message. All done. The key to truly understanding the states is understanding the independent steps in forming a peer. Establishing a TCP connection starts with the connect. The BGP session starts with the open sent, followed by open confirmed, and lastly, if everything goes well, being established. But what happens when all does not go well? Router 1 sends a TCP request to router 2. For some reason, the TCP connection fails. Router 1 transitions to active and sets a timer. Router 1 will not attempt to initiate a TCP connection with router 2 until that timer expires. It will, however, listen for and accept incoming TCP requests. When you see the active state, it means that the local device tried to form a TCP connection, but it didn't work. Active helps to distinguish between when the process is doing nothing, like an idle, and when it did something and is just waiting to try again, as an active. A TCP connection is formed between router 1 and router 2. Router 1 sent an open message and is waiting for an open from router 2. The open arrives and router 1 sees some red flags. It doesn't approve of router 2 as a neighbor. Router 1 lets router 2 know that there's an issue or an error in its open and that the pairing won't happen with a notification message. Router 1 sends the notification message and tears down the TCP connection. The state transitions to idle. Gotta start again. This video covered BGP states and messages. Understanding a neighbor state helps determine where the underlying issue is when troubleshooting is necessary.